Northern India Textile Research Association is a prime textile research institute in the country, supported by Ministry of Textiles, Government of India. NITRA was set up in 1975 in 50 acres land allotted by Government of UP textiles and allied sectors. NITRA is recognized by Department of Scientific and Industrial Research, Government of India, and approved by Ministry of Energy, DVB, PCRA, IDBI, CPLB and DPCC. It is only ISO 9001 Certified Textile Research Association. NITRA has Memorandum of Understanding with leading educational institutes IIT Delhi, GCTI Kanpur, TIT Bhiwani, IIT Kharagpur, Lady Irwin College Delhi, Women Polytechnic Delhi and Anna University Chennai. NITRA has 12 technical divisions. Northern India Textile Research Association has been chosen as the Centre of Excellence for promoting protective textiles in the country. Protective clothing, including garments and accessories intended to protect people from hazardous material, come under the protective textiles category. Protective clothes are the real safety and can save human lives and property from various mishappenings. Nobody can forget fire accident in a theatre in Delhi. It took many lives and is considered most horrible fire accident till now. Fire accident in Meerut was another heartbreaking accident where fire caught in a tent. It was a public function and it claimed approximately 300 lives. These accidents could be avoided with the use of protective clothing. It was found that in both the fire accidents, fire retardant textiles were not used. NITRA is serving nation by taking responsibility of testing textile to protect human lives from heat, cold, fire, mechanical hazards and other troubles. NITRA has recently set up state-of-the-art fire testing laboratory for testing textile material for national and international standard. Let us discuss some important tests. Limiting Oxygen Index (LOI). The limiting oxygen index is the minimum concentration of oxygen expressed as a percentage that will support combustion of a small vertical test specimen under specified test conditions. It is measured by passing a mixture of oxygen and nitrogen over a burning specimen. LOI values for different samples are determined by standardized tests such as IS 13501, ISO 4589 and ASTM D2863. To start the test, specimen of the size approximately 140 mm into 52 mm is taken. Initial concentration of oxygen to be used is selected by burning the specimen in room condition. If the specimen burns rapidly, about 18% oxygen concentration is set in the instrument. If the specimen burns gently and unsteadily, about 21% of oxygen concentration is set. And if the specimen does not continue to burn in air, then an initial concentration of oxygen at least 25% is set in the instrument. Oxygen percentage is set as per the preliminary test. The specimen is allowed to purge the system and the specimen is ignited with the burner and the behavior of the specimen is observed. When it is observed that the specimen continues to burn either for at least 180 seconds or to 50 mm from the top of the specimen. The oxygen percentage is recorded and fresh specimen is lighted at lower oxygen percentage until the critical concentration of oxygen is determined. That is just sufficient to ignite the specimen, and below that the specimen does not get ignited. The concentration of oxygen determined as the oxygen index or limiting oxygen index of the specimen using following relation. LOI is equal to O2 into 100 divided by N2 plus O2. Inclined or 45-degree flammability tester. This instrument can be used to test textile material as per ASTM D4723, ASTM D1230 and IS 11871 Method B. Under this, dried specimen of the fabric is held at an angle of 45 degree to the horizontal. Let us demonstrate this test for better understanding. In this test, 5 specimens are cut, measuring 150 mm into 50 mm. Cut specimens are mounted in their holders and are kept in ventilated drying oven maintained at 105 degrees Celsius plus and minus 3 degrees Celsius for 30 minutes. After 30 minutes, specimen is still in the holder. Cooled by keeping in desiccators or airtight container over anhydrous calcium chloride for at least 15 minutes. Burner is ignited and gas flow is adjusted to give flame length of 15 mm from the tip of the flame to the nozzle of the burner. Flame is applied for 1 second and time in seconds is recorded for the severance of the cotton thread by the flame. Now we will record average time of flame spread for the 5 or 10 specimen, and also the ignition or fusing of the base fabric of textiles having a raised fiber surface. Convective heat tester. With this instrument, heat transmission through material or material assemblies used in protective clothing is compared. Materials are ranked by calculation of the relative heat transmission under the specified test conditions. Under this test, horizontally oriented test specimen is subjected to an incident heat flux of 80 kW per meter square from the flame of a gas burner placed beneath it. The heat passing through the specimen is measured by means of a small copper colorimeter on top of and in contact with the specimen. The time in seconds for the temperature in the calorimeter to rise 24 plus minus 0.2 degrees Celsius is recorded. The mean result for 3 test specimens is calculated as a heat transfer index, which is called HTI. For better understanding, let us see how the test is performed. Specimen is placed on the support frame and the copper calorimeter is placed on the top of the specimen. Minimum of 3 specimens are cut, measuring 140 mm into 140 mm. Prior to test, instrument is calibrated to give 80 kW per meter square heat flux using gas burner. Now conditioned specimen is placed on the support frame and copper calorimeter is placed on the test specimen, and the test is carried out with the help of the instrument. After completion of test, the time in seconds for the temperature in the calorimeter to rise 24 plus minus 0.2 degrees Celsius is recorded. The mean result for 3 test specimens is calculated as the heat transfer index. Radiant heat tester. This instrument is used to assess textile material assemblies when exposed to source of radiant heat. This instrument is used to perform IS 15758 Part 2 and ISO 6942 test methods. Two methods, Method A and Method B, are used for determining the behavior of materials for heat protective clothing subjected to heat radiation. Method A serves for visual assessment of any changes in the material after the action of specific level of radiant heat for a specific time. The level of radiant heat is set by adjustment of the distance between the specimen and the thermal radiation source. With Method B, the protective effect of the material is determined. For better understanding, let us demonstrate this test. For carrying out the test for Method A, conditioned test specimen is mounted on the test frame and the specimen is exposed to a specific heat flux. Appearance of the specimen is examined for any changes. Example, discoloration, deposits, smoldering, charring, rupture, melting, shrinkage and sublimation. Method B. Conditioned test specimen of dimension 230 × 80 mm is mounted on the calorimeter. The specimen is exposed to a specific level of radiant heat. The time for temperature rises of 12 degrees Celsius and 24 degrees Celsius in the calorimeter are recorded. Heat transmission is recorded as RHTI. Molten Metal Splash Tester. This instrument is used to assess resistance of materials to molten metal splash as per IS 15758 Part 5 and ISO 9185 test methods. In this test method, the specimens shall have dimensions of 260 mm × 100 mm. And then the small quantities of molten metal may be aluminium, copper, steel or iron, which is poured on the specimen supported at an angle to the horizontal on a small pin frame. Damage is assessed by placing a PVC skin directly underneath the test specimen. And the damage to the skin after pouring should be noted. Any adherence of the metal to the specimen surface is also noted. Depending on the result, the test is repeated using a greater or small mass of metal until the minimum quantity to cause damage to the skin is observed. To test the high visibility of textile material, two instruments are used. One is retroreflectance meter and other is spectrophotometer. High visibility of the textile material can be judged in accordance to EN 471 or IS 15809 specification. These instruments are used to test the high visibility garments worn by workers or engineers working in roadside location or other similar location where the movement of traffic is high. Retroreflectance meter is used to test retroreflection property of retroreflective materials, while the spectrophotometer is used to test the fluorescence property of the background material. High visibility garments are made out of two components: fluorescent material and retroreflective material. Fluorescent material that re-emits optical radiation at wavelengths longer than it is absorbed. This material is considered to be the background material in the high visibility clothing. Retroreflective material that reflects the light emitted by a light source back to that source, but spreading out into a very narrow cone. And now there is another type of material, which is combined material. material with combined fluorescent and retroreflective properties, performing both properties simultaneously. Classification of high visibility garments. Classification is based on assessing the extent to which the wearer is exposed to risk, which is task load, nature of work, color and complexity of the work, environment, and lighting. Performance Class 1. For low-risk environments, lowest levels of fluorescent and reflective materials are used. Minimum visible area of background material should be above 0.14 meters square. Minimum visible area of retroreflective material should be above 0.10 meters square. Performance Class 2. For moderately severe environments, balance of fluorescent and reflective materials is required. Minimum visible area of retroreflective material should be 0.13 meters square. Performance Class 3. For use in most severe environments, it offers the greatest amount of fluorescent and reflective coverage. Minimum visible area of background material should be 0.5 meters square. Minimum visible area of retroreflective material should be 0.2 meters square. Pass or fail criteria. For fluorescent material, fluorescent yellow should have minimum luminance factor, which is 0.70. Fluorescent orange red should have minimum luminance factor, which is 0.40. Fluorescent red should have minimum luminance factor, that is 0.25. Retroreflection. In this, specimen is measured at the two rotation angles 0 degree and 90 degree, and material having coefficient of retroreflection that differ more than 15% are defined as orientation sensitive. Minimum coefficient of retroreflection in CD/lux meter square for separate performance material level 2 at 12 observation angle and 5 degree entrance angle shall be 330. Minimum coefficient of retroreflection in CD/lux meter square for separate performance material level 1 at 12 observation angle and 5 degree entrance angle shall be 250. After exposure at different conditions, the coefficient of retroreflection in